Okay, so let's do the backdooring. So for our target, we need first of all we need a target. Okay, so I picked putty.exe, which is a popular SSH client for Windows. Now, in this case, this is 32-bit application. Okay, but and it doesn't matter actually. The process of backdooring 64-bit applications is the very same. So we are dealing with 32-bit process, okay? So how do we start? First, for the 32-bit process, we need to, or programs, we need to use 32-bit debugger. And let's open our target application. Okay, so putty. Let me just fix this up. Oh, I can stay. Okay. So let's go to the entry point. So breakpoints, there is also always one-time entry point set in the debugger. So what do we have here? We have some two pushes, so some arguments are pushed on the stack and then the call is down and so on and so on. So what we need, first we need to find our code cave. And usually, since we are in text segment, text section or segment in memory, at the end of allocated segment, you can usually find some space which is not occupied. You can see there are a lot of zeros here. Okay, so this is our code cave. Okay, so let's first, what we can do, let's set up a breakpoint here, just for the reference, so that we can easily find it. Okay. So we have our code cave, and at the same time we can also copy the address. Let's open up our notepad. So code cave address is this one. Okay. Now let's get back to the original entry point. And now for the backdooring, we need to copy this. What we actually need to do, we just create a jump to our code cave at the end at this address. Then we put our shellcode there, and we will jump back to this code. Okay. If we do the jump here, we have to override several instructions. So let's copy several of them, copy selection, and save it in our notepad. Okay. And now we can assemble. So hit space, and we just do jump and our address, which is this one. Paste. Okay. Now, if you set your cursor on this instruction and hit enter, as you can see in the window which pops, there is a 0. So if you hit enter now, we land in our code cave. Okay, so the first stage to jumping to our code is set. Now, as we could potentially copy our shellcode here, but since our shellcode will change the state of the machine, which is the registers, instruction pointer, some values on the stack, what we usually do first is we save all the values of the registers and all the values of flags onto the stack. So we can use two instructions. Push AD, which will push all the values of the registers. Okay, here is the first one. And the second one is push FD for flags. Okay. So once again, our code jumps to this instruction, and then we save the registers and flags on stack to keep them safe. And now we can paste our shellcode here. So let's make some selection, or you can just scroll down and press the shift and keep the shift pressed and just left click. Okay, so we selected some space. Now we need our shellcode. So we have a prepared 32-bit of shellcode for the calc here. So we just select this, copy, we get back to the debugger, we right click, binary, add it, and here you just press Control V, like paste. Okay, and if we go back to, yeah, this is our shellcode being copied here. All right, so we are almost done, but we need so let's save these changes. So let's save the changes and see how it works. So we click patches, select all, patch file, and now let's make a copy like putty2, save, and let's open putty2. Okay, so I can go here, let's hit enter, and let's set the breakpoint here or F2. So we go back here, we run again. Okay, we run again, we hit our code cave now, and if we run, hopefully it will launch our shellcode. Okay, and the calc has popped up, but if you can see here, the program has exited, so putty didn't run, and that was expected. So let's reopen it again. Let's go to the debugger, and so this case with this particular shellcode is really interesting and not that uncommon. So usually what we are aiming at is that shellcodes are independent block of code that you can paste anywhere in wherever you want and use that as is. Now, in this particular case, it is not, because after our shellcode launches our calc, it will call some sort of exit or something similar, similar function. So one of the things you could do, you just go through and analyze the whole shellcode, which is really tedious. But instead of that, we can just try to locate where this exit call is being done, and just skip it or override it. Okay, so what we do, we set breakpoints on every call in our shellcode. So this is 1, hit F2, F2, F2. Okay, that's all. Okay, so let's run it. So we land in our entry point and jump to our cave. So we had enter, run again. Now we're here. So let's run it again. Now this call. So if I run step over, nothing happened. Okay, so let's hit run again, and again, and as you can see, after that call, because we hit this breakpoint, so after that call, this call runs our shellcode, runs our calc. Okay, so we can even set a comment here, calc launched. Okay, now we know that this part. So again, let's hit another and see if the program will exit or not. So no, this call is safe. So the last one is here, and it probably is that call. So let's run it. Yep. Okay, so we have confirmed that the last call is the call to exit. So let's reopen again our shellcode. Let's go to the last breakpoint, and yep, this is it. So now what we have to do is to get rid of that. All right. So what you can do is first you have to what we can do, we just jump out of that code and jump back to the original putty code. So and remember, if we want to we have overwritten these instructions, so we have to restore them and then jump back to this call. All right, so how can we do it? As you can see, we have some spare space here. So let's first jump out from that push somewhere here. So let's say we will jump to this address. So we just copy address and assemble, and just jump here. Okay, so when the CPU, when the instruction pointer hits this instruction, it will jump out into here. Okay, now what we have to do next is we have to restore the original context of the CPU. So as you recall, as you may remember, what we did before the shellcode was to save all the registers and flags on stack. So now what we have to do is we do the reverse operation. So we hit assemble again, and we pop FD, which will restore the flags register, and pop AD, which will restore all the registers. Okay, so we are almost done. The last thing we have to do is restore these two instructions. Okay, so what we can do, let's go here, paste, and just get rid of this. We don't need this. We just copy the bytes here. Okay, so copy. Now let's select some space binary edit, and now Control V. So paste and OK. And now we have restored our overwritten instructions from the PuTTY beginning. And the last thing we need to do is we have to jump to this instruction. And this instruction address is here, so we copy this address. Again, assemble, jump, OK. And let's see if we jump back. So hit enter. And yes, as you can see, we are safe. So what we do, we do again patches, all the changes we've done in this binary. So patch file. Now let's save it in number 3. Okay. Let's open up a new budget version of PuTTY. And again, we have our breakpoints. Nope. So let's go there. Let's hit enter. Let us set the breakpoint here. So F2. Let's scroll down. As far as I remember, this was the call where the calc has popped up. Okay. Now let's set the breakpoint here and the breakpoint here. Okay. Oh, that's okay. It's okay. Let's start. So we jumped into the entry point. Now we hit F7. Okay. So F7, step over, F7, yes, step into. This is our push AD. So let's go F7 again. And again, and as you can see, the stack has saved all the registers. So for AD0, yes, these one, FF94, FF94, etc., etc. Okay, and now F7, you will see this register being saved. As you can see, 246. Now it has changed because we used push instruction, and now our shellcode begins. So if we scroll down and hit F9 or run, now we can step over. Our calc has executed. Okay, that's so far so good. Now if we hit run, we should land here. So run. Yes, we are here. Nothing happened. Now let's step into again. So we will land here. All right. So we are here. And now take a look at flag eFlags register. F7. It has restored the value from the stack. Now take a look at the registers. When you have F7, yeah, the registers has been restored. Okay, and now we are actually starting to execute the original code from PuTTY. So now if we run let's push. Let's do it. So F7 again. This value went to the stack. We are here. It's here. Now F7 again. The next value has landed. And let's hit the last time the F7. And we landed back to the original code of PuTTY. So let's run it. And bingo. The PuTTY is working. You can run, change anything. It seems like okay. So let's cancel it. Let's close the back and let's close that. And let's just hit F5 to refresh. And PuTTY 3 is our final version. So let's check it out without debugger. So double click. And it's successful. So we successfully backdoored PuTTY with our shellcode, which was our task. Cool. Let's move on to the next section.